Okay, so hello, good afternoon, right, from New York. We're having today the AIFI Winter Bootcamp 2021 information session. My name is Miquel Noguer. I'm the CEO and founder of the Artificial Intelligence Finance Institute. Right, so we're hosting our, this is going to be our fourth cohort. So we're we founded the Institute a couple of years ago. Michael Weinberg, who's now at Managing Director of Hedge Funds at APG, at that time was leading Protege Partners in New York, and also professor at Columbia. We founded the Artificial Intelligence Finance Institute. The idea is, and our mission is to basically be a world leading educator on the application of artificial intelligence to investment management, capital markets, and risk. Right. So we'll see, and you will see. Please, by the way, ask questions, right? This is not some sort of a lecture, this is not, so you can obviously ask questions at any time. What I was saying is that we think it's one of the best educational programs, right, geared towards investment professionals, banking professionals, also risk professionals to understand and implement cutting edge artificial intelligence, machine learning techniques. So we'll see that we are providing some sort of everything that leading academics and practitioners know about, well, supervised learning and supervised learning, reinforcement learning, and natural language processing. So the way we choose to do that is through, these boot camps, right? And the boot camps are, right, we'll see what is the agenda for next bootcamp, but around 45 hours of maths, code. We'll give you a lot of slides and a lot of actually implementable code. So TensorFlow, Keras, scikit-learn, and Python, all in Python. We will have during the bootcamp, I'll show that, also MATLAB and data robots. So we'll see, the bootcamp is pretty much hands-on, but we also have data robot and MATLAB. This is, one of the best AML tools out there. Okay, so this is me, right? As I said, I co-founded Artificial Intelligence Finance Institute. I'm also the head of development at Global AI, and there are things not here, but I'm on the advisory board of the Quant Investing Group in the CFA Society of New York. I'm also editor of the Journal of Machine Learning in Finance, and I worked for UBS during 10 years. At that time, I worked as Chief Investment Officer of the European region, Chief Investment Officer at Antbank, and I am teaching currently at NYU Courant in New York. Also been teaching at Columbia University for 6 years. Right, I have a PhD in quantitative finance. And we have been working for the last, I would say, 6-7 years, right, on the implementation and research of machine learning techniques to finance. So we'll see that today. So basically merging econometrics, machine learning, inventing new disciplines as reinforcement learning in finance, and also natural language processing in finance, which we think it's have a tremendous future. In the faculty, we think we have literally, I would say, the best professors, right, and practitioners in the United States, and we're obviously happy to have also people from India like Sonam, but we have some of the leaders on the industry teaching on the bootcamp. Obviously, we all know Marcos Lopez de Prado, who's now at Abu Dhabi Investment Authority and professor of practice at Cornell, right? And 20 years experience, AQR, Guggenheim, so an author of several books, of several really interesting books. So Marcos, is a pleasure to have Marcos with us. Gordon Reeder, who's a scientific advisor, going to deliver a talk for us, has a PhD in mathematical physics at Harvard University. He's leading right now Reader Alpha, and he's been prior at GSA. And Gordon, as some of the other professors, he teaches basically all leading MFE programs like Baruch, NYU, Courant, where I'm also a visiting researcher, and he's an avid researcher on basically, as you know, for example, reinforcement learning and all areas of portfolio management. We have Peter Cole is professor and he's on the lead of the Mathematics in Finance Master Program at Quran Institute of Mathematical Sciences. Peter's been writing several books, and he's also been writing several very interesting papers this year about machine learning, about reinforcement learning. So basically, okay. It's also a pleasure to have Matthew. Has been in all 4 programs so far, right? Matthew is a British applied mathematician. It's professor of applied maths and Illinois Tech. He's been working, and he's co-founder of Thalessians, and he's been working on Barclays, Lehman Brothers. So Matthew, as we all know, it's an extremely accomplished combination of academia and practitioners, and obviously, right, for the ones who are in the field. So we will be using his books. So Matthew Dixon, Igor Halperin, and Paul Bilocon wrote a book this year about machine learning in finance. So Matthew Dixon is going to be teaching some of the stuff that it's in the book, right? So it's a good opportunity also, and it's obviously good reference. So the book Machine Learning in Finance, written by Matthew, Igor, and Paul. We've also added this year, right, 2 other very distinguished professors. Tim Lung is the full professor of applied mathematics department at University of Washington in Seattle, right? He's leading the computational finance risk management program in University of Washington. He was previously a colleague of mine in Columbia University. And we also have Sonam Srivastava. She's a quantitative researcher, and she recently wrote a book with, an interesting paper with me, right? So I think this is a good, just let me show quickly. We also have, right, on our advisory board, right? In our advisory board, we have some of the most important, right? So we have Janet Wing, we have Peter Carr in our advisory board, Armando Gonzalez from Ravenback, Hein Handel, Emily Spratt, Vlad Kandros, who's giving us insights on high frequency trading. So we also be discussing during the course, the bootcamp, so aspects related to market structure, liquidity strategy. Michael Weinberg, who's the co-founder, right? Okay, so we have a really really interesting. Okay, so now let's, any questions so far? Okay, so let's deep dive. Okay, and just, we also have from two other experts, Miki Adba, he's a associate professor called in Spring Harbor Laboratory, and he's a world expert in unsupervised learning. So I wouldn't miss, right? He's been delivering for us the unsupervised learning, right? Lecture on these 2 years, also joining us in 2021. And we have Larry Rudolph, who's researchers at the MIT, has a very long, distinguished career on computer scientists, on NYU, Quran Institute of Mathematics, Carnegie Mellon, University of Toronto, right? Again, he's really, I would say, a giant on computer science. Deep learning. So he's going to be teaching the deep learning piece. Okay. Just other things that we do in the Institute before digging more into the contents, right, is these are some of the papers we wrote. So they're recent, they're really recent, right? So we wrote a paper, deep reinforcement learning for asset allocation in US equities. So a new approach to use and implement reinforcement learning to do portfolio allocation, right, in US equities. So we go model free. We use deep neural networks to go from time series to the weights, right, of a portfolio, while also considering, right, transaction costs. Okay, so this is one of the things we're also doing. Obviously, we will see the code and the maths during the bootcamp. We also wrote another paper also on deep learning, but in that case for time series prediction, right? Along with Gilberto Batres, who's going to be teaching the coding, right? So Gilberto is going to be teaching, as he's done, the teaching. The coding, the Keras, the TensorFlow, right, and scikit-learn. Also with Aymeric Moulin, who's at GP Morgan. We've also wrote a paper, right, on a different subject, but this is obviously always related to finance and the application, implementation of AI. Right, is sustainable investment, exploring the linkage between alpha, ESGs, and SDGs, along with Malin Anton-Schich, Geert Bickhardt from Columbia, Richard Rothenberg, and myself wrote a paper. Right, so we've been working very hard. this very special 2020, right, on delivering research, right, on open source research. Okay. So,
excuse me.
Yes, please.
Can you just summarize your findings? And ESG, did you find the ESG factors have significant signals in this paper?
Yeah, so in the paper, basically, we established the fact that, for example, using ESG momentum, it's a really interesting way to not absolute, but ESG momentum, for example, using MSCI signals, ESG momentum can really help portfolios. That happens in a variety of different contexts. We measure something, we measure sentiment, for example, using NLP, and we see that what really contributes the most is it's oftentimes not the absolute value of a signal, but the changes in the signal. And we also explore the SDG Sustainable Development Goals use on in a portfolio context, right? Always using NLP, natural language processing, going out there, web scraping, reading stuff, and then finding different ways to measure sentiment, right?
Okay, thanks.
Yeah, you're welcome. Okay, so what will the bootcamp again is the fourth time, right? We've had 2 bootcamps physical, right? We were holding the bootcamp at NYU NYU Tandon in Brooklyn. The first 2, obviously this summer has been January 2020 we had the second, and the third was this August, and we do it fully online, right? So this obviously these days, there's no other way, and we're pretty happy about the way it worked, right? So we split the what was 1 week bootcamp into 2 week bootcamp, 2 weeks, in order to make it right, in order to make it some sort of smoother, right? Given that it's online, so we all know that online it's a different format, but we're pretty happy about the delivery of the different lecturers and professors. So Zoom, it's a good way to teach code, to teach maths, right? To ask questions. And then we obviously record the lectures, right? So then it's all available, right, for you guys to just to have it, right? So lectures are online, right? 10 days, obviously not the weekend, just the 5 weekly days. We'll see that now. It's around 40, but we finally had 55 recording hours, right? Because we extended some lectures, because we invite new speakers, right? So we'll see now exactly the context, but we think it's really top in the sense that we see maths, we see code. So every day we see lots of maths, we see lots of code, and then we have practitioners speaking about their experiences. Okay. Then for the ones who are interested in being evaluated, right? So we offer an exam on July 2021, right? And a project is going to be in October 2021. So you'll see that there's a lot of materials, but you have 2 years, right? So you have 2 years. If you think that first year, you sometimes delegates think that there's a lot of materials to absorb, right? So you can pass it in 2 years, right? I'll elaborate a little more later on. Okay. The fees, you have a discount, an interesting discount before 11th December, so you still have a little bit of time to think and ask us questions and so on. 15% until 8 January, and if some of you we'll always invite some sort of we offer scholarships, right, for young students. So we've had PhD postdocs from Columbia, NYU, right, in all the first 3 cohorts, right? So okay. So people, for example, people working with NYU AI or machine learning, like close collaborators of Jan LeCun and so on. Okay. Okay, so what's before digging into the agenda? So I'll make a quick tour on the agenda so you see what's going on every day. So we already have planned it. So remember, it's the 4th day. It's the 4th time. So we pretty much have found some sort of the format that we think gets the delegates engaged. And they can make out the most. So it's about mathematics. So it's not. So sometimes people think or tells me, well, AI is not exactly right. We think this is a quant finance course, right? Clearly, right? Because we'll be exploring stock picking, multi-asset portfolios, risk management, some banking applications, trading, high frequency, okay? And but we'll not spend a lot of time on financial intuition, right? So we obviously assume that you guys know what's a bond, what's a stock, okay? So we assume that some financial sort of financial knowledge. We assume that you have financial knowledge, right? So we won't be going through we will focus on, as we will see, supervised learning and supervised learning, DL, so deep learning, reinforcement learning, and right, NLP. We, except the first day that we will, right, some sort of obviously give a little bit of context. Okay, about coding, right? So we'll offer, here we say 7 notebooks. Actually have, let me show you, actually have much more already, because we've been actually, right, we've been actually publishing so many papers that we have some sort of more than 15 notebooks, right? So we have 15 notebooks that start with the basics of finance, you know, time series, autoregressive models, GARCH, BARMA, portfolio optimization, fundamental factor models, and so on and so forth. And then we start with some sort of the machine learning piece, right, in which we have supervised and supervised ensembles, right? Okay, we have a bunch of materials on obviously on SDEs, simulation statistics, Levy processes, right? As I said, ARMA models, BARMA models. Okay, and then we have, for example, right, examples of ensembles, you know, right, boosting, bagging, random forest, and so on. And we'll also have on the 10th day and 9th day, right, lots of really very interesting materials on natural language processing. And when I say materials, it's things that actually work, right? So not only theory, but you know, very interesting notebooks that allow you to, right, to actually do stuff, right? So I think this is also one of the main benefits of taking the course. The amount of code we have on deep learning, reinforcement learning, and NLP, I think it's very interesting. So with, at least ourselves, we've worked a lot. And again, the good thing about having Matthew, that having Larry, that having, right, Gordon, and so on and so forth, is that we've all not only work on theory, but also on implementation. So we bring, we will offer, right? Okay, so can the course be taken without any some sort of computer science or Python knowledge, right? The answer is yes, but it's obviously pretty challenging, right? So for the ones who, for example, don't know much about coding or maths, so it's important that you tell us in advance so we can give you the references, right? Okay. Okay, so day one, right? So let me just go quickly through the specific contents. So day one, we some sort of offer, right? I offer, right, an explanation of, right, big data in finance modeling. I haven't spoken about data, but obviously AI, machine learning. So things have changed in finance in the sense that we were basically dealing with very specific structured data, right? Factors, time series, prices, volumes, and so on and so forth. And we've had to, we expanded that to alternative data and so on and so forth, right? So the first day we're going to be talking about big data in finance modeling. and we're going to start with supervised learning algorithms, right? So, okay, super vector machines, right? Trees, linear regressions, on classification and regression. So, right, we'll have as a speaker William Kelly. William Kelly is the CEO, Chief Executive Officer of the Kaya Institute, and William is also on the board of another institution which I collaborate, the Financial Data Professionals Institute, that offer a certification. That it's a very interesting one, right? It's obviously not the same level of depth and sophistication that our course offer. Okay, the second day we'll have very interesting day, right? So George Lensas always provides. George Lensas is now it's a lecturer at Columbia University. He's also Springfield Capital, and he delivers an absolutely outstanding discussion about something very important in finance, which is, you know, model selection, pre-processing, overfitting, and so on and so forth. So you know that there's a lot of debate on the community as to whether, right, you know, deep learning, machine learning need to be used, and it overfits or not. Can we control that? So George Lensas have a wonderful discussion, right, about estimation, learning, model selection. Then we will start coding. So Gilberto Batres, who's senior data analyst, and he's been writing 3 papers with us on deep learning in finance. So he's going to start with Python and the basics of Python. So the first day, actually Tuesday, February the 2nd, you'll have, right, a Python primer. So 1 hour, probably more. Then we will have 2 other giants, right? We'll have Olga Kane. She's an expert on basically alternative data hedge funds. So you can follow her on Twitter or LinkedIn. She's at Navid, right? And she's working in a hedge fund. And we'll have as a keynote speaker, Eigil Halpering. Eigil Halpering is one of the authors of the Machine Learning in Finance book, and he's a fantastic speaker, researcher, professor, practitioner. So you'll have a lot of fun. And okay, the third day we devote the day to trees, right? So trees are extremely interesting in different applications, right? As a supervised learning technique, so we can use trees individually, so to speak, right? Trees are non-parametric, so to speak. So trees are built as if some sort of if-then-else conditions, right? And one of the most interesting applications of trees is building, right, several trees. So doing ensemble models. So Yashoing Zheng, right, is gonna be talking us about bagging and boosting, so random forest, and then some of the models that perform best in the different Kaggle competitions, right? So in different Kaggle competitions, we see XGBoost like being an exceptionally well-performing technique, and Yashoing Zheng, it's an expert. One of the other experts on XGBoost and factor models is Tony Gida, right? I'm sure you've also heard about Tony. Tony is the author of 2 books, right? And he's a practitioner for more than 15 years. And he recently wrote a book about machine learning factor modeling, right? So he's going to talk us about that. Okay, another important aspect about AI machine learning in finance, right, is the importance of explainability, right? So MATLAB, MathWorks, and Marshall Alfonso, he's been speaking to our delegates for several years already, and MATLAB has a lot of experience, right, on how do we make models that are actually explainable to supervisors, to clients, and so on and so forth. So Marshall delivers a really fantastic talk about the issue. On day 4, we have, you see, very interesting day 2, Miki Adval. As I said in the introduction, Miki Adval, right, it produces an outstanding lecture on unsupervised learning, right, and the connections to on unsupervised learning and learning, right, and information theory, right. So don't miss. We always have, right, and delegates have always given us extremely good feedback on this unsupervised learning lecture. The second code session with Gilberto Batres. So here we start with scikit-learn, right? For the ones that who were, right, you obviously, right, will do lots of scikit-learn, right, and supervised learning, right, relies a lot on the fantastic package scikit-learn, and Gilberto is gonna teach this second Python session and focused on scikit-learn. Then we will have another talk from a very distinguished member, right, of the quant finance community, like Per Kolm. Per Kolm is going to talk us about reinforcement learning, very hot topic, right? So we'll have in the bootcamp, I would say 5 of the best authors on reinforcement learning in finance. So Gordon, Peter, Igor, Matthew, right? We also wrote interesting paper. Then we'll have Data Robot. Data Robot, as you know, is one of the leader AML platforms heavily used in the financial industry community, right? And William is going to give us some sort of a 2-hour tour on the use of AML platforms in finance. Okay. The 5th day, right? So on Friday, we have another exceptional, right? I would say lectures, because we have here, right? We have François Charton. François Charton is from Facebook AI. He wrote 2 fantastic papers about the use of transformers, the use of deep learning to perform mathematical computations, right? So the idea of deep neural networks learning, right, how to integrate, how to differentiate, to do ordinary differential equations and several other tasks is just unbelievable. So Francois is going to give us a talk about deep learning for mathematics, right? After that, Larry Rudolph, right, is going to give us some sort of the first, a deep lecture on deep learning, right? So as I said, Larry Rudolph has a really long experience on computer science at the MIT, at NYU. He's currently at 2 Sigma, right? So he has a wealth of, right? And then to just close the first week, we'll have a keynote from Marcos Lopez de Prado. So I'm sure everybody in the audience knows Professor Marcos Lopez de Prado is one of the most prolific, best in terms of the books he's written, his experience on the use of machine learning algorithms in finance. So it's really for us a pleasure and a privilege to have him on board. I also teach in his Cornell class, right? His professor of practice at Cornell. So, okay. Then we will start the second week on the 6th February right? Michael Weinberg from APG is going to talk us about machine learning in finance in general. There's a lot of things and that can be discussed. So Michael will be covering that, and then we'll have one of the masterful, right, sessions from Matthew Dixon. So as I said, Matthew Dixon is one of the also, right, really best authors and practitioners in the space, right? He's written this fantastic book, Machine Learning in Finance. He's going to deliver for us two magnificent lectures, one on day 6 about deep learning, looking at basically recurrent neural networks, long short-term memory networks, GRUs, and so on, right? So Matthew's going to be talking us about that. And then after his lecture, we'll have a high-frequency talk. So Vlad Kandros is in our board. He's one of the right. He's head of market structure and liquidity at UBS, right, in New York. So he has a large team of, high frequency and some sort of liquidity traders, right? He's gonna deliver for us. Then we have after him, right, Emmanuel Perez Arribas. He's a young researcher, right, working on a very special area of finance, right, which is Terry Lyons 20 years ago invented, created, right, for us a new tools in probability theory, the rough paths, and some sort of an extension of the rough paths, right, is signatures, right? So Emmanuel is going to talk us about signatures in finance. Okay. Okay, the seventh day, right, we'll talk about reinforcement learning, right? We'll start with reinforcement learning, as I'll see, I'll define a little bit after, right? Yeah. So reinforcement learning, right, is some sort of a very general framework, right, to deal with multi-choice problems in finance. So there are lots of problems in finance in which are multi-temporal choice, like portfolio allocation, like hedging, and like trading, right? These all these problems can be modeled using reinforcement learning, right? So we'll see how we can use reinforcement learning in dynamic replication and hedging. Is also obviously going through, you know, the main theoretical aspects about the taxonomy of reinforcement learning, model-free, Markov decision processes, tabular learning, Bellman equations, and also deep reinforcement learning, right? So, okay. This very same day, we'll have Marco Kangra. Marco Kangra is head of quantitative research at Ravenpack, right, who's one of the leaders of natural language processing in finance. And Marco is going to give us a very, very interesting session on, right, NLP. So how we can measure sentiment, right, reading text. And as I shown before, right, so we have several notebooks. Okay, so we have several notebooks that literally go from a financial data set, which was labeled, that take the work embeddings that can be obtained, for example, using the Globee 300 NLP Stanford data set. Okay, so you get this embedding matrix, right? And then you can use recurrent neural networks in order to measure sentiment. Okay, so we'll also offer, as I said, so he's okay. So oftentimes, as I said, we'll be using slides, but we'll also be using Python notebooks. Okay, and after him we'll have Said Amir, right? He's the author, right? Along with Alexander Denev, they wrote a book about the Handbook of Alternative Data, right? So Said is an expert on alternative data. As Olga, so remember we have Olga Kane, she's going to talk us about alternative data. Said Amir is also going to talk us about alternative data. And he wrote a fantastic book, right? Again, the Handbook of Alternative Data, just very recently, so I think it's a couple of months ago. So it's a really very good book to some sort of understand how new data sets can be used in different finance tasks. Okay. Now, the day 8th, we will do a second, right, reinforcement learning lectures, right, as you all know, right? So reinforcement learning is some sort of mathematically and probably more complex even than deep learning, right? And so it really pays off, right, to some sort of obviously have 2 lectures fully devoted to reinforcement learning. So Tim Leung from University of Washington is going to be giving a second lecture on reinforcement learning, then a practical session of reinforcement learning with Ivan Zankin from JP Morgan. Right, so then we will have Aitor Muguruza. Aitor Muguruza is a London-based Spanish practitioner, quant finance practitioner and researcher, and he's going to be talking us about deep learning and option pricing. So you see, so deep learning can be used for prediction, can be used for pricing, can be used for risk purposes, can be used for density modeling. So we'll see basically all the different uses of deep learning in the different areas of finance. And we'll have a coding session, right, with Gilberto Batres. On date 9th, okay, I be delivering, we also have 2 days of natural language processing, right? So natural language processing is the artificial intelligence that basically deals with text, right? And how we can some sort of perform different tasks using NLP algorithms. So I'll describe the NLP pipeline, the need for text pre-processing. So one of the series really surprising things about doing natural language processing is the sheer huge amount of text that it's out there. You web scrape, you find millions of articles of for example, the top 50 S&P 500 stocks. You have really millions of articles, right, every month, right? So text pre-processing and the computational challenges of dealing with such huge amounts of text, this is something we're going to be discussing in this first lecture. We're also going to be discussing, right, word tokenization, right? So how we actually convert, right, or transform words into vectors, right? So how we can tell algorithms, how we can tell Python and TensorFlow, this is the word bank, this is the word algorithm, right? So how do we need to tell the machine, right, that this word, so a lot of work has been done on transforming again these words into tokens, right? So things that actually a computer can understand. We'll discuss in depth how we can use, so how we can first do frequency methods. So frequency methods is that we're looking for a specific topic, I don't know, revenues, and the first things that come to, or the first thing that researchers did was, okay, let's look out for words, right, that might indicate, so this text is about Apple revenues, right? Okay, so we'll discuss the traditional TF, IDF, and so on, frequency-based methods, and we'll start discussing about the use of NLP, deep learning, the use of deep learning in NLP. So we connect this lecture with the previous lectures in which we've discussed recurrent neural networks. But we first discussed recurrent neural networks, long short-term memory networks, to model sequences of returns, of prices. And here, recurrent neural networks are used in order to, right, basically model sequences of words, right? Okay, so we will have then Ting Hao Li. Ting Hao Li is a brilliant Chinese researcher working for a hedge fund in New York, right? Has a couple of masters in financial engineering, data science. So he is gonna show us how to do NLP with notebook, and also using BERT, right? So one of the latest natural language processing models. And then we have as a speaker Justin Zen from Thingnum. So Thingnum is one of the leaders of also NLP in finance, right? With a lot of experience into web scraping and transforming all this messy information into actually insights that can be used for investing purposes. Okay, and finally, on the last day, we have a very strong day too. We'll finish, you will use an hour to just wrap up, right, and have a debate, right, the delegates and myself about you know, the different challenges and the different opportunities and the different risks of using AI in finance. Then we will have three other talks. One is Dogu Arachi. Dogu Arachi is a Turkish researcher that wrote a book about, a paper about using BERT in the financial context. So he's going to talk us about that, right? So the use of BERT in finance, right? BERT is, before GPT-3, BERT was arguably the best model out there to perform many NLP tasks, right? So, okay, before concluding, we will have one of the giants of, I would say, quantitative finance. So Gordon Reader was Quant of the Year 2019, right? Because he's been doing a bunch of work, very good work on reinforcement learning, machine learning, in portfolio allocation, in option pricing. So it's really a privilege and to have also Gordon Reader. And then we'll have Richard Rothenberg from Global AI, who's going to talk us about specific uses of AI in order to measure ESG related issues, right? Okay. So this is, right, I think I've provided a pretty good, you know, I think that this is really, we're really giving the delegates, right, the best materials, the best notebooks, right, really on this specific area, right? Any questions about? Okay, no questions. Okay, other things, you know.
Sorry, yeah. Is there any discount for students?
No, but we can offer scholarships, right? We can offer scholarships that go from waiving the fee if it's a right, if it's a PhD a student and we actually invited them, some of them, right? If it's other students, we can provide a student discount. Yeah.
Okay.
Yeah, that can go to 50, right? But we're really sensitive, right, to different situations, so to speak. But it's never been an issue that, right? Yeah, we think the price is obviously right. We think it's a reasonable price considering what we give, right? We're obviously happy to have young people, people that has issues. We can have, again, be sensitive to different situations, right? Now that it's online, it's easier, right? When we were short on capacity because of NYU Tandon classes not being huge sometimes, right? But now online, we have more flexibility to provide, right? We can give also partial, right, access to, right? There's really lots of different situations in which we can. Yeah.
How do you, the project, if I decide I want to do the project, how does it work? I just tell you I want to do the project and I start working on something, or there's some sort of discussion with you or with somebody else?
Yeah, we have a committee that basically vets, right, all the projects, in the sense that we want a project that it's interesting, right? And so if you choose to do the project in October, right, it's in January we give a month in which you, right, after the exam, the theory exam, right, it's good if you come with a proposal, and then we have to approve that proposal. But we do that in all the courses we teach at the university, because we think that it's important, right, that the student is working into the right direction. You see what I mean?
Yeah.
They're not working in a problem that it's arguably, right, arguably too hard, right, or arguably too easy, right, that it's not going to bring, right? So in that sense, it's more difficult to evaluate. But anybody has had issues with that, right? Just to be clear, right? I mean, if you find right, yeah, projects there, you pick it up, a data set, and then you some sort of tell us what you want to do: prediction, portfolio allocation, risk, pricing, density modeling, and so on. Okay. Yeah. Okay. About the cohort size. The cohort size was, when we were doing it physically, we had in January 75, right, which was the max capacity in NYU, right, and online we were unlimited. But anyway, they should be more or less the size. We just don't want to have too many people, right? But we have enough resources to cope with questions, and you'll see we have a platform that it's called Piazza, which is the one that's used by several universities. And there, right, let me see if I can show. Give me a sec. Okay, so Piazza, we're using this platform, okay, in which every day, right, okay, in which every day, okay, we have the lecture recordings, right, and obviously all the resources, right, and as I said, the resources is just really massive, right?
Yeah.
Okay.
It's amazing.
Yeah, so you have all the lecture notes every day. So there are around 1,000 slides, right? Okay, you see this is the slides. Here you have the code. Okay. Yeah, so we have yeah, a fair amount of things. But by the way, that doesn't mean that the exam is going to be super hard, right? So we know that. So the first part, I'll talk about the exam, maybe just to answer another question. right? So there's a comment from somebody says, I finished my quantitative master 10 years ago, right? And I need to catch up with AI topics. So I'm working a PhD thesis, right? Yeah, we'll provide several references, right? A good start, it's obviously, right, the machine learning in finance course. So there, let me see. Machine learning in finance course. Oh, yeah, here it is. Okay, so this is a good reference. Okay, it's an expensive book, but it's really worth, right? So there's also Marcos Lopez book. Lopez de Prado has this machine learning for asset managers. This is also a fantastic book. And I would say there's a one that has a free version. It's ML Factor book. I would probably start with this one, okay? Because it's free, right? You have very good.
Can you paste the link, please, in the chat?
Yeah, yes. It's yeah, this is a free book. Well, this is at least you can have it a physical copy, or you can have access to their website.
Okay.
And the others were yeah, the others were machine learning in finance, from theory to practice, right? Yeah, this is a very good reference. Okay, and then Marcos Lopez de Prado, it's another excellent reference. Okay, now about the coding. Okay, about the coding, because these books are they're all provide very good. If you don't have a coding background, right? I know it might sound a little bit, right, to start with this book, but I really like this book, right? So this book is a really fantastic one. Okay, the hands-on machine learning with scikit-learn, Keras, and TensorFlow. This is just, I think, the best book, right, to learn machine learning, right? And it has extremely good GitHub, right, repository with all the chapters. So when we teach big data, not in finance but in general, we really recommend this book. This book is not that expensive, right? But it's a really outstanding reference. Yeah. Yeah, so I'm trying to, yeah, somebody's asking about MATLAB. So yeah, we think that one of the things that, yeah, obviously there's a lot of people using MATLAB, right? That's obviously why we choose Python. We basically choose Python, right? Because it's widely used. It has a fantastic TensorFlow, right? So let me show you, right? There's obviously scikit-learn, which is a fantastic reference. With scikit-learn, it can be your machine learning book too, right? You see what I mean? It has examples, it has the maths, it has the code. So scikit-learn documentation is just also fantastic, right? So you can learn ML here, right? But it's still think that spending $38 in the Aurelian's Jerome book is not it's not a fortune, right? It's money well invested. And then we have TensorFlow for deep learning, okay, which has extremely good tutorials, right? okay? They're not finance, but this is our job, right? So to speak, our job will be, it's just to mix this with finance, but also TensorFlow tutorials are just fantastic, and they're pretty new. They just updated them in September, right? So they're pretty fresh, right? And you know, for example, I really like the time series forecasting, right, of TensorFlow. Okay, one of the interesting things about taking the course is that it's you'll see it's not anymore only about finance. All these things can be used, right? You know, in many situations. So time series, that was the way we modeled, right? So time series problems, and now you can solve IoT problems, Internet of Things that are basically sequences or physics problems, like temperature modeling, right? Or obviously COVID, or things like that. Yeah, so I think if somebody has a MATLAB background, I think this is a perfect course, because you will add Python, which is very important, right? Very important, because it still has MATLAB, but Python again is very flexible, and all the papers, right, that are being produced, you have, right, PyTorch, right, and Keras. We will focus more on Keras, but we are ourselves now learning PyTorch, because there's a bunch of good stuff using PyTorch, especially language models, time series models, and so on. Okay. So yeah, so let me. Okay, so I have many other slides, but I think these are slides that basically show some sort of the materials, right? This is basically what we're going to cover: supervised and supervised reinforcement and NLP. And you see, when you see that, we always tell students and practitioners, you see, okay, so we've been, to some extent, we've been working in a subset of the models we can use, because we've been focusing mostly on linear regression, in factor models, time series models, right? And now we have at our disposal a bunch of nonlinear regressions that can be, you know, XGBoost or deep neural networks and so on. And then we have something that we barely learned with econometrics, which is classification models, right? The fact that, you know, we have problems that are better solved by using classifications. For example, ratings, right? So you want to say how AAA, AA, A, and so on and so forth, right? So now we can easily put together sophisticated nonlinear classification models using trees, using softmax regressions, softmax classification neural networks, and so on and so forth. And supervised this, so too, right? It's some sort of a very interesting, right, place to look at, right? There's a lot of work to be done in finance and reinforcement learning. So reinforcement learning, so this idea that you want to learn policies, right? As I said, intertemporal choice are something extremely important in finance, right? Because of portfolio allocation, because of delta hedging, trading, and so on. So all these problems can be framed as reinforcement learning problems, in which you want to maximize the amount of rewards that you have, right, in given states. And what you want to learn is the sequence of actions, right? You want to learn a policy. What's the optimal policy to do something, right? To put together a portfolio, to training, and so on and so forth, right? So reinforcement learning is a really, really, I think, fundamental tool for the future, right? Okay, so this is basically the kind of algorithms that we're going to be looking at. So lots of them. Okay, so from linear regressions to ensembles, decision trees, a lot of a lot of work on neural networks, multi-layer perceptrons, so the dense neural networks, CNNs, long short-term memory networks, so the recurrent neural networks, and another family that is getting more popular by the moment, which is market generators, right? You can do market generators using variational autoencoders using restricted Boltzmann machines, for example, right? So this is a pretty popular hot space right now, right? Market generators. So how can you enhance and create new market data? Okay, so we'll see a lot of multivariate stuff, ANNs in depth, artificial neural networks, with its activation functions, layers, and so on. We spend a lot of time on a fair amount of time on short-term memory networks, which you can see in our recent paper, which been invented by Hochschreider and Schmidhuber on 1998, being heavily used in language problems. So NLP is based on basically long short-term memory networks, right? Okay, RL problems, lots of code, stakeout of encoders. We'll also see a little bit of transformers, which is the new generation of neural networks that deal with language, right? Hopefully, but at that time we'll have some new research we're working on transformers for time series. Transformers have been basically used for their problems like that. So we have a problem with which we're trying to learn a model that it's been able to finish that statement. So pandas in the wild eat, right? Okay, and we need to figure out what's going to be next word. So okay, so it's so mathematically, it's like we need to some sort of compute what is the word that has highest probability, right, of being there, conditioned to, right, the text in the sentence, right? And the way you do that is first, you do this idea of embedding the words into vectors, right? So pandas is going to be now a vector of 300 potentially entries in the wild, and then you use a mechanism of attention, right, in order to look out in the past, right, about these words in similar contexts, right, and then be able to some sort of produce an attention output that looks at basically, right, all the text you have available, right? It's like a search, so to speak, right? SQL search, okay? And then, you spit some sort of the word that is most likely to be after that, which is bamboo, right? Okay, so we'll see a little bit of that. And yeah, this is about the evaluation. The exam theory would be 6th of July. So we give a fair amount of time after the exam. We know you will work or you will study, and many students took it, right? And many students are still taking it. So we think it's the first is open book. So obviously there's a huge amount of different models, but we think that it doesn't make sense to some sort of ask questions, memorize, or just to ask you dry questions. It's going to be open books in the sense that we ask you a question that is not in the materials, but it's like if you are in a professional setup, right? You're being asked a question, your boss has asked you a question, so how can you explain mathematically XGBoost, for example, right? Something that, right, you can obviously will go through, and maybe so you have to, or things about error square, or how we measure the different models, right? Or grid search. There's a bunch of things that are essential that we can ask, and that you'll have access to the materials to answer.
How many how many questions typically the exam is?
Yeah, the exam is 10 questions, right?
Oh, okay.
3 hours, right? And yeah, it hasn't, I say, if you know, we've been very fortunate because our experience with the delegates is everybody has been extremely engaged since day one, right? Working hard, attending all the lectures, asking lots of questions, right? We're very happy about the student engagement, right? Delegates were really, really excited about the materials and about passing the exam. The second, I've touched it a bit, so it's about on 5th of October 2021, and it's about producing an interesting, you typically would say that this is, for example, something similar to a Kaggle, right, competition, right? So it's kind of similar, right? We think it's so, but the idea is that so the course is basically about algorithms, right? So we don't want to, for example, work in problems in which data is a biggie problem, right? You see, it's very hard to get stuck in a language problem because it's the first time you do language and you've never dealt with data sets that are so complex. So maybe we can give you a data set, a text data set, so you can play with it, right? So this is what I mean by that. Okay, and that's a bit it. Yeah.
Thank you.
Yeah. So as somebody has been asking on the chat, so yeah, we think it really makes sense. It really makes sense if you've done your MFE, your master, or a few years ago. It makes sense, to come and see with some of the best minds in quantitative finance how we can some sort of make the transition to a new world, right? That opens up a bunch of opportunities, right? In terms of, I have big data students that some of them after finance now they are Instagram or Facebook or right? So for one example, right? It's like, machine learners these days are also very versatile. So they work in language problems, and maybe they might be like Francois Charton, so, right? And maybe they're working in a language problem, and the next project is how we can embed mathematical equations to these transformers so they can learn, right? They can learn from millions of equations of integration and differentiation and so on. So, okay, so that's why we think that it really makes sense to spend a couple of weeks working hard with these issues, and yeah, we have during these 10 days we also have time to ask a bunch of questions, discuss things, and yeah, you can also send us an email, and you can also reach out to me on LinkedIn, right? If you have questions, right? Yeah. Let me give you mine in case, right? Excuse me. Yeah. Let me give you to everybody. Okay. So this is mine. You can either send me an email or reach out on LinkedIn, right? There's another area of collaboration. We're always interested into doing research. So if anybody is interested into writing a paper, exploring something, we're more than happy to, right, discuss projects, right? Yeah.
Actually, my main purpose to take this class is to write the paper towards my final chapter in my PhD. So yes, I am very interested in that. I have the data set and I have everything. So I don't know if I need, I don't want to take your time or anybody, but just that was my motivation, and I would like to publish it or write a paper. So if you
we again in the following the course, you can ask questions about specific the areas that you have. There's an additional thing is that we're in the institute, right, also eager to publish papers. So if we converge into if we can converge into something that we all think it's interesting, so why not?
Okay.
Right? Yeah.
Thanks.
Yeah. Okay. Okay. So it's been a very interesting session. So I thank you very much for your time. I hope that you guys are going to be able to make it. Right. We think that, you know, these are challenging times. So these are not easy times. Right. From day one, we just thought we need to continue. We need to basically, even if in August, for example, right, it was, you know, obviously, but we had a very good response, and everybody was so engaged that we think that even if it's online, it makes sense to take it. In the future, it's going to be again physical, hopefully, right? So it's obviously a pleasure to be in New York, at NYU, and so on. But yeah, the virtual experience was also fantastic. So I think it really makes sense. Yeah. Okay. Okay, guys. So thank you very much. Right. I hope, yeah, we'll see us in February, or right. Just send us an email. Thank you.
Okay. Thank you.
Thanks, guys.